Okay, in this video we are going to cover the solution to the exam 2 problem where this is a top-down view of a large tanker being hit by a small yacht. The force of the yacht on the tanker is 2 million newtons. The mass of the tanker is 100 million kilograms. And in an early part of the problem you already found out that the moment of inertia of the tanker was 53 billion kilograms per kilogram meter squared. So we were trying to find the acceleration of point B. So the acceleration of point B, the way we're going to get that is we're going to get that as the acceleration of the center of mass plus the acceleration of point B compared to the center of mass. And to get the acceleration of the center of mass, we'll use sum of the forces equals total mass times the acceleration of the center of mass. And there's only one force acting on this object, which is the 2 million newtons. So to find the acceleration of the center of mass, just take the 2 million newtons and divide by the mass of the tanker, and we get 0.02 meters per second squared in the I-hat direction. Okay, so that's our A bar. And now to get the acceleration of point B, we will put that in here. So that's again negative 0.02 in the I-hat direction, nothing in the J-hat direction, plus now the acceleration of B compared to G we'll write in the R-hat and theta-hat direction. So we'll look at a different coordinate system, the radial transverse coordinate system of B compared to A. So first thing we need to do is identify the R-hat direction. Which way is it? Well, if we're looking at B compared to A is the center, so the R-hat direction will be that way. Now how about the theta-hat direction? The theta-hat direction is going to be such that R-hat cross theta-hat is K-hat. So the theta-hat direction is going to be that way. Okay, the idea is we're trying to find the acceleration when we first get hit by this yacht. So this first term for the R-hat direction is 0. It's got the R double dot. That's 0 because it's a solid object. This is B compared to A. And the second term is R theta dot squared, and that's 0 because it's not yet rotating. So the R-hat component is 0. This component down here, 2R dot theta dot, again 0 because it's a solid object. Finally, plus R, which is from A to B, so that would be plus 40, times theta double dot, which is alpha. And that's not 0. Okay, so our acceleration of point B, the acceleration of point B is negative 0.02 in the I-hat J-hat plus 40 alpha in the theta-hat direction. And the theta-hat direction is the, looking at the picture, the theta-hat direction is to the left. So it's negative 1 in the IJ. And of course this over here is IJ. Again, if I don't write the subscript or the If I don't put them on there, we're assuming it's ij. Okay, so we're almost done. We just have to find alpha. So to get alpha, we'll use sum of the moments equals I alpha plus, this is if you get the moment of inertia with respect to the center of mass, plus r cross ma, and this r is from the point that you're doing the moments about compared to the center of mass. So let's do the moments about the center of mass, in which case that goes to 0. So we've got the moment about center of mass, which is point A, would be 2 million newtons times, this was 30 meters. So this was 60 million Newton meters. That equals our I times alpha and the k hat. So the alpha you could just get by dividing the 60 by the 53 times 10 to the 9th, and that works out to be 0.00112 radians per second squared, and then take that, plug it in for alpha. So this gives us, for this term, negative 0.045 meters per second squared. Oops, sorry, I don't know why I put a negative sign here. It was positive there, and it should have been positive there. It should be positive here. Obviously, the boat as a whole is going to move to the right. So this gives me, though, positive 0.02 plus negative 0.045. So a grand total of negative 0.025 meters per second squared in the I hat direction. So this is the acceleration of point B. So in other words, point B here, and this is of course meters per second squared, point B is moving, accelerating to the left. So the boat as a whole is accelerating forwards, but twisting. So even though the boat as a whole went forwards, point B accelerated to the left. So the answer was negative 0.0